Um, in this video, we're actually going to explain how the whole concept of differentiation by the power rule works. The process of finding the derivative can be found using the concept of first principles, but you've seen that first principles is actually very long. Right? There's a shortcut of finding the derivative by just using what we call the power rule. The power rule is not the only rule that you can use to find the derivative. There's something called the product rule, there's the quotient rule, there's chain rule, there's many concepts, but in the context of high school, you only need to know the power rule, right? So let's see how the power rule works. So basically, what you need to know is if you have any function, if you have a function, right, a function that is in the form, maybe let's just say a function is equated to some coefficient, x here, and some exponent. In this case, my function is a function of x, right? The derivative of this, the derivative will be as follows. The derivative of this kind of a function will just be you multiplying the exponent and the coefficient. So you just multiply this exponent with that coefficient and multiply it by a will just give me na, right? And on your exponent, you just subtract 1, and then it's going to simply be n minus 1. And it is always the case. So what you simply do is you take whatever the exponent you have, you multiply with whatever the coefficient you have, and then that will give you the new coefficient, which is n times a. And on your old exponent, you subtract 1, which is going to be that n minus 1 you see, which becomes the new exponent on your derivative. Now, the function can take different shapes. It can take different forms. So let's see what are possible forms. So if I am working with a question that has a function as maybe f of x, if they say to me f of x equals to some terms, right? The derivative of this kind of a function will be denoted by f prime of x. So this is the notation we use to denote derivative, right? Sometimes we don't give you f, we give you a function in the form of y. So we'll say to you y equals to something, right? And when you derive that, the derivative will be change in y over change in x. But we write it as follows. We write it as dy divided by dx equals to whatever you're going to get from the derivative. The third type you get is where we just put a capital letter D and a small x at the bottom there, and we put our expression inside brackets like this, and we ask you to derive that. If the function appears in this form, then we don't have anything that looks like this one for the derivative. So you just simply go straight and then you put your answer without any complications. So that's actually how you're going to do it. So if f of x is the function, the derivative is f prime. If y is the function, the derivative is going to be dy over dx. If you've got d with a small x and the expression appears in brackets, then you just go straight and you write your answer without any challenges. Right. So now the derivatives are not limited to just one derivative. Sometimes we ask you to do multiple derivatives on a function. For example, we might ask you to find the second derivative or the third derivative. So the second derivative means you derive the first time, and then on your derivative, you derive again. So you're deriving twice on the same thing, right? Or the third derivative will mean take your function, derive it the first time, derive it again, and then derive it for a third time. That will be the third derivative. So in the context of f and y, if I give you f of x, if I give you f of x, right, the first derivative will be f prime of x. This is the first derivative. If you derive this again, you're going to get the second derivative, and that is denoted by 2 primes there. So f double prime of x means second derivative. We might also go further to find the third derivative, which will now be 3 primes of x. So you can go on and on and on and do exactly that. For y, if I give you y as my function and I ask you to find the first derivative of that, it's going to be dy divided by dx. If you want to find the second derivative, it looks very weird. It is actually d square y over dx squared. And if you must derive that further to find the third derivative, it will be d cubed y divided by dx cubed. Right. Now in high school, we are just limited to the second derivative. You don't go to third and more derivatives. You just stop at the second derivative. So this is how the notation looks, and it's very, very important, because if we give you f, you can't start talking about y's in a question that is talking about f. The last thing that is important that I might want to share with you is if you have these functions, they're not only limited to y and x. Sometimes we give you a function of a particular variable as a function of another variable. For example, area as a function of the radius, right? If area as a function of the radius, you must derive area as a function of the radius, where you have a of r equals to something there, and you want to derive that, then you can have the derivative as a prime of r, right? Or if you had a function of area where a equals to some function that has got a radius on it, when you're doing the derivative of area with respect to the radius, you're going to do dA over dr. That means the derivative of area with respect to the radius. You can derive anything with respect to anything. Maybe somebody else wants you to derive, maybe I'm thinking p as a function of q. If you want to derive p as a function of q, then you will have dp divided by dq. Another one that is popular is working out height, maybe versus the radius. You want to find the derivative of height with respect to the radius. That will be dh divided by dr. So this is to say we are deriving the height with respect to the radius. So it's not only limited to x's and y's. You can have other variables that you could be dealing with. And in physics, for example, they've got velocities as functions of time. Then if you want to find the derivative of velocity as a function of time, then you'll have something that looks like dv over dt. This is to say the derivative of velocity with respect to time. So we can have many, many different derivatives as a function of different variables, depending on what your function happens to be a function of, which one is independent and which one is dependent.